This is 1.4, part 2. We'll talk about perimeter and area of polygons in a minute. We just talked about the different types of polygons and then whether each is convex or concave. So I'll go through a couple of examples in the dark shaded area here, exercises 1 through 4, even though we probably won't go through all of them. It says classify. That's also naming the polygon by the number of sides and then tell whether it's convex or concave. Maybe it's easier to do the second part first, but I'll just do things in order. So example 1, however you want to keep track of things, you can just count off the number of sides. 1, 2, 3, 4, 5 sides right here. So even though it might not look like the pentagon, like an aerial view of the pentagon, this would still be a pentagon. So you often know the specific names of polygons by the number of sides. And then these two sides specifically determine the type of polygon it is. Okay, since it's basically indented, or it looks like it has a cave, that would be a concave pentagon. Pentagon that's concave, or a concave pentagon. On these 4 examples, even though I might not go through all the parts of all of them, number 3 out of the 4 is the only other concave polygon. Okay. But then on number 2, again, just count up the number of sides. You can refer back to that table. At some point or another, you should probably study that table if you don't know all the different names of the polygons that are listed on the table. So I have 1, 2, 3, 4, 5, 6, 7, 8 sides. It's an octagon. And then, as I mentioned, only number 3 is the other concave. So this would be a convex polygon or a convex octagon. And then a couple of things that you can find of any polygon are the perimeter and the area. Okay, perimeter. First of all, a perimeter is always measured just in your basic units. Whoops. And so by basic units, if you know the side lengths are given in inches, then the perimeter would be measured in inches. If each of the side lengths are given in terms of centimeters, then it'd be measured in centimeters and whatnot. Different than when you measure area, which we'll talk about in a little bit. But the perimeter is just the distance around a figure. That's one way that you could say it. You measure distance, you just measure it in your basic units. If no units are given, you would just write units or abbreviated U. So a few instances where you could use perimeter. Okay, say you're building a fence, you probably want to measure the perimeter if you're putting baseboard around your room or house. If you know what the baseboard is, it's just like the trim that goes along like the floor and then the bottom part of your wall. Okay, those are a couple of instances when you could use perimeter. Again, perimeter is measured in your basic units. And then another thing that you can calculate of a polygon is the area. When you're calculating the area, you measure in your square units or units squared, whatever those units may be. Okay. If your units are given to you in terms of feet, then the area would be measured in square feet. Square yards, square centimeters. If no units are given, then it would just be units squared or square units. And the area is basically the amount of space enclosed by a figure in a plane. So going through an example, some of the formulas that you may need for the area, for example, the area of a triangle. If you don't remember, it's either area equals 1/2 base times height, or some of you might know it as base times height divided by 2. It's really the same thing. To calculate the area of a rectangle, it's length times width, and so on. So you might need to, say, look up the formula if you forget the area of a figure. But going to my example at the bottom of that screen there, I want to find both the perimeter. So just a reminder, when we're measuring the perimeter, I'm just going to measure it in regular units. No units are given here. It might be something like, even though I expanded or kind of enlarged the figure there, it might be something like the grid paper is 4 squares per centimeter or 4 squares per inch or something like that. No units are specifically given, so I'm just going to measure it in units. But I want to find the perimeter and area of that polygon with the given vertices. So I'm going to graph the polygon. I'm given 4 vertices, so the polygon should have 4 sides. I'm going to plan ahead, 5, -3, 5, -6, 2, -6, 2, -3. I'm looking at all the points there. All the y coordinates are negative. So instead of making my x-axis right in the middle, my y-axis right in the middle, and then possibly not being able to fit all the points onto my graph, I know that each of those points are in quadrant 4. So I'm going to put the x-axis a little bit higher than in the middle. I'm going to make this my x-axis, and then this is my y-axis. And I'll label each of them. But to graph each of the points, remember you start at the origin first, then it's x or right or left first, then y, up or down next. So 5, -3, 1, 2, 3, 4, 5, and then -3. I'm going to label each of the points. This is point D. 5, -6 is point E, right here. Point F, 2, -6. And then point G, 2, -3. And so this is polygon, or more specifically, quadrilateral. You can probably also see that it's a square, which also means it's a rectangle. We'll go through quadrilaterals in a different unit, all the different names for quadrilaterals, but it's quadrilateral DEFG. That's one way that you can name it. So if I actually draw out the sides, when you're naming a polygon, whether it's a quadrilateral or anything else, you name it by basically tracing it out. So from D to E to F to G, and then basically back, to D. Sorry about my writing there. Although I wouldn't call the quadrilateral DEFG D, even though I'm going from G back to D. Another way that I can name that polygon is something like polygon GFED, okay, because if I go through each of those vertices, that traces out the polygon or quadrilateral as well. There are certain things that you can't name this quadrilateral. I can't name it something like quadrilateral or polygon GEFD, because if I go from point G to E, that's not a side of the quadrilateral. It's what's called a diagonal. So again, you can't name it something like GEFD because that doesn't trace out the quadrilateral. But I still want to find the perimeter and then the area. So to find the perimeter, I'm just going to add up all the side lengths. All right, there's a quicker and, in my opinion, easier way to do it. There's a more longer way to do it. I don't know, for some people it might be more complex, but to find the length of each side, okay, it's a little bit easier here because each of the side lengths are either horizontal or vertical segments. Okay, if they weren't, then we can go back to 1.3 and then specifically use the distance formula to find the length of one of the sides. On some of the problems that you're working on, you might need to use the distance formula or possibly the Pythagorean theorem. Okay, but GD, that's 3 units in length. Again, no units are given, so I'm not going to write anything like 3 centimeters or 3 inches. DE is also 3 units in length. You can just count the number of squares, basically. FE and then GF are also 3 units in length. So first of all, the perimeter, just label it the perimeter. Keep in mind it's going to be just your basic units. So if you take the sum of all the sides, 3 plus 3 plus 3 plus 3, or just 3 times 4, the perimeter is 12. And then it would just be units, and I could abbreviate it 12U. To calculate the area, I could use the formula for a rectangle, length times width, or base times height. I could also use the formula for a square, a side length squared. So base times height would be 3 times 3, a side length squared, 3 squared, which is the same as 3 times 3. So the area would be 9, and in this case, square units. So I can actually double check that, maybe not from my drawing because it's kind of bad, but there are actually 9 squares enclosed by the figure GDEF. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's kind of a way to check. Might be a little bit more difficult if you didn't have full squares, like if you had a partial square. But that's calculating the area. Again, this one was a little bit easier because all the side lengths were either horizontal or vertical segments.